Biomass cooking stoves present a unique set of public health burdens, especially in developing countries like India, where an estimated 400 million people use these stoves on a daily basis to provide food for their families. Almost 80% of Indian households, especially in rural areas, use biomass stoves inside the home where ventilation is often poor and concentrations of indoor air pollutants can be high. Biomass stoves are notorious for incomplete combustion of fuel sources, causing exposure to polycyclic aromatic hydrocarbons, carbon monoxide, benzene, and other particulate matter. Chronic obstructive pulmonary disease, or COPD, is one of the most prevalent negative health effects associated with biomass stoves. In an effort to contribute to existing scientific knowledge on improved cook stove designs, our capstone team captured the efficiency, carbon monoxide exposure, and user-centric considerations of a prototypical three-stone stove often used in India and an improved cook stove commonly used in the United States. The team measured how efficiently each stove boiled water and cooked a standard Indian dish, the level of carbon monoxide at two different working distances from the stove, and surveyed local residents on which stove they thought would be best suited in a typical Indian home. Our testing began with the adapted water boiling test, and we measured the time it took each stove to boil a small amount of water, as well as the useful energy used to boil said water. Surprisingly, the three-stone stove achieved boil in less than 8 minutes, whereas the improved cook stove never reached boil after almost 15 minutes. The three-stone model also used significantly less fuel to achieve boil, and the improved stove consumed almost all of the fuel. Next, we measured the time to cook a typical Indian flatbread, roti, as well as the fuel used. And again, the winner of the cooking efficiency test was a three-stone model. Our quick conclusions as to why the three-stone model was so efficient is directly correlated to the height of the cooking vessel to the flames. Also somewhat surprising was the fact that the three-stone model performed better in terms of carbon monoxide exposure at both working distances from the stove. So in regards to overall performance, the simple three-stone model was the clear winner by a wide margin. However, the surveyed participants all seemed to favor the overall design and potential functionality of the improved stove. The team thought this due to potential cultural bias, as the improved stove is used widely in America. The test results, coupled with feedback from the survey participants, enabled the team to generate a list of design recommendations that would improve the performance of the improved cook stove. Lowering the cooking grate closer to the flame was primary, followed by the ability to divide the burn chamber and cooking area for situations that called for a smaller cooking capacity. Additionally, the team suggests that the overall height of the improved cook stove be lowered due to customary cooking practices in India. Finally, the team suggests that a chimney be added so as to divert harmful carbon monoxide gases away from the user. Cost to complete these changes would need to be considered, and most importantly, whether or not the improved cook stove would be adapted and used by the populace at large in India. We thoroughly enjoyed this project, and it is our hope that our recommendations can somehow be used to lessen the various burdens associated with biomass cooking stoves in India. Thank you.